Okay, for today's assignment, let's do the right portion of things. A sequence which terminates is called a finite. First again, is called a finite sequence. Terminate means to stop. That's a finite sequence. A blank is an individual number, figure, a letter in a sequence. A term is. A blank is a pattern involving an ordered arrangement of numbers, figures, letters, or objects that is called then a sequence. And a sequence which continues forever, that's an indefinite. Sorry, I don't know where I got the word indefinite from. An infinite sequence. Okay, then we asked to do practice 1 through 4 right here. Okay. So on the practice here, consider the first two terms, 28 and 14. So that's not enough information right now to determine what is going on. So what they want us to do is determine whether the sequence is arithmetic or geometric. Explain your reasoning. And like I just said, not enough info. It could be either one, okay? It could be arithmetic, it could be geometric. There's not enough information with just two terms. You need to have at least 3 to figure out a pattern. So in question 2, they are specifically saying now it is arithmetic. Determine the common difference. So I'm looking for some type of either addition or subtraction occurring. In this case, 28 to 14 means the determine the common difference. D equals for common difference. We are adding a negative 14. Okay, sorry, trying to get this all situated. All right, and then list the next 3 terms. So if we're doing a negative 14, continue it on. We start off with 28, we went to 14, and then we continue to 0, because 14 minus 14 is 0. 0 plus negative 14 is negative 14, and negative 14 plus a negative 14 is negative 28, and so on, okay? Letter C, determine where the sequence is finite or infinite. Explain your reasoning, and it will be infinite. It will continue on forever. There's no reason why this thing cannot stop. Now let's say it was geometric. So 28 to 14, how are we going from 28 to 14? And it's got to be geometric then. So we're not adding or subtracting, we're decreasing, so we are either dividing by a number, or another way to say this is multiply by the reciprocal of that number. And we always go with multiplication. So the common ratio then is, how do we go from 28 to 14? The common ratio, R for ratio, we are multiplying by a half. We can see we divided by 2, but again, the ratio should always be written as a multiplication. Dividing by 2 is the same as multiplying by a half. So list the next 3 terms. 14, so we're starting off at 28, we're at 14. Okay, 14 times a half is 7. 7 times a half is 7 over 2. And then 7 halves times a half, multiply numerators, multiply denominators, going back to 3rd grade, 4th grade, 5th grade, where you start multiplying fractions through your elementary years, grade school years. So then 7/4, and it will continue on and on and on. So I say continue on and on and on, and this will be then an infinite sequence, because we can continue to multiply by a half and continue to get a 7/8, 7/16, and so on. Using the first 2 terms, 20 and 14, write the next 3 terms of a sequence that is neither arithmetic or geometric. So if I'm going from 20 to 14, let's say I went down by 14. Now let's say I'm going to go down by 13. So 14 minus 13 is 1. And then I'm going to go down by 1. I'm going to go down by negative 12 then. So 1 minus 12 is a negative 11. And then I'm going to go down by 11. So then I'm at negative 22. Then I'm going to go down by 10. So negative 32. That is my non-arithmetic, non-geometric sequence, okay? We want to do then review 3. So let's go find review 3. Okay, review 3. Using your graphing calculator, all right? We want to determine what is going on with this function here, or each of these 2 functions. So I'm going to go ahead and graph this function. So I'm going to bring on my graphing calculator here, as you should bring on your Chromebook. And there it is. So let's go do this. First thing is, it's going to be quadratic. The function family is quadratic as it's an x squared there. So let's type it in, 5x to the second, and then minus 2.8x plus 40. So I know it's going to be quadratic. I know it's going to be u-shaped because of the x squared. So let's see it. And the same thing happens on their homework. Why they do this, I do not know. So let's go hit zoom up here and let's hit zoom out for number 3. Zoom out. We're going to repeat that, number 3. There it is. There's my U-shaped graph, okay? So from there, we can see it is U-shaped. This is decreasing. It turns right here to be a minimum, and then it turns up to be increasing. Decreasing, minimum, increasing. So let me go back to my screen here, and let's fill that out. I said this was quadratic. It was first decreasing, then increasing. It had an absolute minimum. So this was what the graph looked like anyway. And then it was, I guess you would say it's a curve. I'm going to say it's a U-shaped graph. It's a curve. U-shaped graph. It's a smooth curve. U-shaped curve, U-shaped graph. Either one's fine. The next one there, 30x minus 550. It's just an x to the first. I know that is going to be a linear graph, and I know it is going to be, well, either increasing, decreasing, or constant is the other option. So when I go graph this next one here, okay, let me get that going. I'm going to go through and clear out the y equals and type in 30x minus 550, hit graph. And as I can see from there, my graph starts way down here and it's increasing. So it's going down to up, so it's an increasing graph. So let me go back to my notes. Okay. So we had a graph that looked like this. It was increasing only. It does not have either one. Okay, a linear graph will not there. And this was just a line. Okay, that should do it for today.